Hi everybody, today we're going to talk about using the normal distribution with Excel. In Excel, when we want to use the normal distribution for the probability that the distribution is less than a value x, we'll put in norm.dist, then the value of x that we're looking up, we'll enter the mean for the distribution, the standard deviation for the distribution, then say true to get the cumulative probability distribution. If we want the probability that x is greater than a given value of x, then we'll do 1 minus norm.dist with our value of x, the mean, standard deviation, and true. Remember, Excel only gives values less than the given value that we enter. So when we want to find something greater, then we always have to do 1 minus the value when x is less than x. When we want the probability that x is between two different values, say x1 and x2, then we find norm.dist of x1, the larger values, with the mean, standard deviation, and true. Then we subtract norm.dist of x2, the mean, standard deviation, and then true. Let me show you what I mean by going to Excel. For our first example, we'll use a mean of 14, a standard deviation of 3.9, and start by finding the probability that x is less than 16. In my cell, I type equals. I type norm.dist, parentheses. I enter 16 with a comma, 14 for the mean, 3.9 for the standard deviation, and true to say cumulative probability distribution. Right now it says it's a value of 0.7, but I'm going to extend my cell so that I can see more values. Now I have 0.69, 596, I would call that 0.6960. For the probability that x is greater than 7.4, I need to remember to do equals 1 minus norm.dist, parentheses. 7.4 is my x value, 14 for my mean, 3.9 for the standard deviation, and then true for cumulative. This gives me 0.947. To find the probability that x is between 11 and 15.7, I type equals norm.dist, my larger value, 15.7, mean of 14, standard deviation 3.9, then true. Close parentheses, subtract. Do norm.dist again, this time put in the smaller value of 11, comma, mean 14, standard deviation 3.9, and true again. This gives me a value of 0.447766626. We would call that 0.4477. Let's try some applications. The volume of an espresso is normally distributed with a mean of 0.85 ounces and a standard deviation of 0.08 ounces. We're going to find the percent of the espressos that are between 0.8 and 0.9 ounces. Then we'll find the percent of espressos that are over 1 ounce. I started with the sheet where I wrote in my mean of 0.85 and my standard deviation of 0.08. I want to find the probability that x is between 0.8 and 0.9. In my cell, I type equals. And because I have two values, I know to start with the larger, norm.dist, my larger value 0.9, my mean 0.85, standard deviation 0.08, and then true. Subtract norm.dist, parentheses, smaller value 0.8, 0.85 mean, 0.08 standard deviation, and again true. This gives me 0.468, and again, if you want more digits, just open up the cell to give it room to write in the extra digits. To get the probability that x is greater than 1, greater than says you start with 1. So I hit equals 1 and then minus norm.dist, parentheses, 1 for my x value, 0.85 for the mean, 0.08 for the standard deviation, true, says the probability is 0.0303964 or 0.0304. Our next problem says, assume the weights of quarters are normally distributed with a mean of 5.67 and a standard deviation of 0.07. If a vending machine will only accept quarters weighing between 5.5 and 5.8 grams, find the percent that will be accepted and the percent that will be rejected. To find the probability that X is between 5.5 and 5.8 grams, I'll start with norm.dist and I put in the larger value of 5.8. I enter the mean, 5.67, the standard deviation, 0.07, then I put in true. Close the parentheses, subtract. Norm.dist, put in the smaller value, 5.5, followed by the mean, 5.67, the standard deviation, 0.07, and then again put in true. This gives you 0.96077. We'll call that 0.9608. To find the percent of coins that will be rejected, we do 1 minus the probability they're accepted. So that's 1 minus 0.9608, which says 0.0392. Our last application says the number of people that ride an amusement park roller coaster is normally distributed with an average of 1,200 passengers per hour and a standard deviation of 300. We want to find the percent of time there will be less than 800 riders per hour, more than 1,500 riders per hour, and between 1,000 and 1,650 riders per hour. In Excel, we set up the problem, and we'll start with finding the probability that we have less than 800 riders per hour. I type equals norm.dist, parenthesis, 800 is my X, 1,200 is my mean, 300 is the standard deviation, and then true. We'll extend our cell to see more values. We have 0.0912. Next, we have the probability X is greater than 1,500. Because it's greater than, we start with 1 minus. Then we have norm.dist, parentheses, 1,500, the mean of 1,200, standard deviation of 300, and then true. This gives us 0.158655. We'd call that 0.1587. Finally, to find the probability X is between 1,000 and 1,650, we type equals norm.dist, the larger value of 1,650, the mean of 1,200, standard deviation 300, true, minus norm.dist, the smaller value of 1,000, the mean 1,200, standard deviation 300, and then once again true. This tells us the probability is 0.6807.